Our next set of notes deals with preparing solutions by using a stock solution that is more concentrated that we have on hand. Um, if we have a more concentrated solution and we need to make a weaker solution, all we have to do is simply dilute it with water. But we need to perform some kind of calculation to figure out how much water we need to dilute it with. And that's where this equation comes in. This equation is the equation that will relate the concentration and volume of the stock solution that we have on hand with that of the new solution. And if we multiply the molarity times the volume of the stock solution, that is going to be equal to the molarity times the volume of our new solution. So let's look at an example of this. It says, how would you prepare a 100 milliliter or prepare 100 milliliters of a 0.4 molar solution? There's our new solution that we're trying to prepare from a stock solution that is 2 molar in concentration. So there's our stock solution. So we need to know how much stock solution we need to get in order to make this 100 milliliters of new solution. So we're going to use our equation. Molarity times the volume of our stock solution is equal to the molarity times the volume of our new solution. It doesn't really matter which side the stock solution and the new solution are on, as long as you keep track of that. But we'll do it just like it says in the equation on these notes. So for the stock solution, we know it's 2 molar. We don't know how much of it we'll need, so that's what we're trying to find. And our new solution, we know that we want to get a 0.4 molar solution for whatever reason, whatever lab we're doing, we need a 0.4 molar solution. And we know we want 100 milliliters of it. Now the beauty part of this particular calculation is that since volume is on both sides of the equation, as long as we keep the volume in the same units, we don't have to worry about whether it's in liters or milliliters. So that makes it nice, and it's actually more convenient for us to keep it in milliliters, since that's how we actually measure it in the lab anyway. So since we're solving for volume here, we simply need to divide both sides by our 2.0 molar. And when we do, it's going to reduce to 1 over on the left or cancel. And over on the right, our molarities are going to cancel. We'll be left with milliliters. So when we divide this, we end up with the fact that we need 20 milliliters of our stock solution to make this new solution. Now, here's the deal. You have to be real careful in the AP test. It says, how do you prepare this new solution? If I get 20 milliliters of this stock solution, and SOLN is a common abbreviation for solution, by the way. If I get 20 milliliters of stock solution and I go back and I pour it into a container and I set it down on the table, I sure as heck don't have my new solution. So I have to dilute it. What am I going to dilute it with? Well, think about it. If I have 20 milliliters of stock solution and I need 100 milliliters of my new solution, then how am I going to get that? You can say it one of two ways, and both are totally correct. You can say that I want to have 20 milliliters of stock solution diluted with 80 milliliters of water, so I can get it to a total of 100 milliliters. I prefer not to do that subtraction, because on an AP test we're liable to do something stupid and subtract wrong on something really simple like this. So I prefer to say it this way: 20 milliliters of stock solution diluted to 100 milliliters with distilled water. And the abbreviation for distilled water is D period H2O. So that's how I prefer to do it, is to tell them we're going to dilute it to the desired volume with our water. Yes, we'll be adding 80 milliliters, but it just prevents us from making a stupid mistake on the test. So that's how I want it stated whenever you do these problems. Now the last example, just be very careful that you pay attention to what it's asking for. This time it's asking how much water you would add to 25 milliliters of 1 molar sodium hydroxide to prepare a 0.75 molar solution. So we're diluting the solution again. We're not reacting anything. We're just making a weaker solution, a more dilute solution. So I'm going to be able to use my M1V1 equals M2V2 equation again. Our stock solution is going to be our 1 molar sodium hydroxide. Again, it doesn't really matter which side it's on, but that's our molarity, and we're going to use 25 milliliters of it. And we're trying to get a 0.75 molar solution. So we're looking for V2. We're going to be solving here in this equation for the volume of the new solution. So solving for V2, we simply are going to divide both sides by 0.75. And when we do, we're going to end up with a value for the volume of the new solution of 33 milliliters. And so we get that 33 milliliters, and we box it, and we move on, and we get the question wrong. Pause it real quick and see if you can figure out why this is not the correct answer. Hopefully you did that, and perhaps you figured out that it didn't ask me what the total volume of the solution is. This is the total volume of the new solution. What it asked me for was how much water I needed to add to the 25 milliliters I already had. So what we actually need to do is to take that 33 milliliters and subtract off the 25 milliliters to determine that we needed to add 8 milliliters of distilled water added. So be careful that you pay attention to exactly what it's asking you for.